Developing composite train structures brings many challenges, from cycle time to communication, process integration, and simulation. CATIA V5 Composites provides a complete suite of process-oriented solutions to design, analyze, and manufacture this structure in a unique virtual platform. It allows capturing all specifications, from material characteristics to zones, geometry, and laminate very early in the process at conceptual stage to create a rough definition of the part and generate preliminary solids for mock-up integration and IML surfaces for tooling and relational design. Customers can then quickly transition from zones to plies while keeping a full associativity with the inputs. Different options are provided to shuffle the plies and obtain a staggered definition with all drop-offs. At the detailed stage, dedicated features help generate design outputs like associative 3D cross-sections, refined solids, and IML surfaces. Associative engineering drawings can easily be created with relevant views, cross-sections, and annotations, and this entire composite dataset can also be natively visualized from a low-end viewer without a CATIA license. DMU Composite Review goes one step further with on-the-fly information and dedicated data query features like core sampling or numerical analysis directly on composite assemblies to check local thicknesses, fly stacking, weight, center of gravity, and cost. Structural analysis can be performed entirely in V5. Composite properties are automatically transferred to the mesh with actual fiber directions, and at post-processing stage, dedicated failure criteria images allow to further optimize weight and strength. Design and manufacturing data structures are split into separate parts to ease data management and concurrent engineering. Manufacturing constraints are incorporated very early in the process, like adding material excess, swapping plies to the tooling surface, checking material roll width compliance, and if need be, splicing the plies according to design and structural constraints. Producibility analysis provides the ability to assess possible fiber deformations, take corrective action by darting plies, and generate the right flat patterns the first time to eliminate trial and error in the shop floor. A new darting feature is integrated to the producibility interface to include various dart shapes and get immediate feedback on fiber distortion removal. From the instantiation of design templates to use of design rules and checks, the integration to the V5 KnowledgeWare platform allows to embed knowledge-based engineering and capture customer know-how whenever possible throughout this process. Downstream operations for hand layup include the export of CPD data to neutral DXF, IGES, and the generation of laser projection data using Majestic Systems True Laser View solution. A drawing-based playbook can also be generated with all relevant information for reuse as shop floor documentation during the layup process. CATIA V5 Composites also addresses alternate manufacturing processes, like resin transfer molding and its variants. The integrated V5 PAM RTM solution from AZ Group simulates and optimizes the resin injection process that will occur later in the shop floor.